Hey guys, it's Mr. Hing here. I hope you are all well. What we're going to be doing today is factorization. However, today we are going to be looking at the method of the difference of two squares. Please look out still for today, where I'm going to be still uploading the trinomial and the grouping method of factorizing. So just look out for that. All right. You'll see that if I zoom out, the previous video that I did was also factorization. However, I looked at the HCF method. So today we are going to get right into the difference of two squares method. Okay, so there are 2 points that I firstly want to highlight, guys, is that how do you know when to use this method? So the first thing that you must do is you must always look out. Can you do the HCF method first? Always do that method first, okay? And then when you can do that, move on. And then look at difference of two squares. Or if you can't do it, then again, you move on and you look, can I do difference of two squares? Now, how do I know if this does apply? So what you do is, I want to bring to your attention that each word in this, the name of this method is significant, okay? So the difference refers to there must be a subtraction sign, okay, subtraction, and then there must be two terms, and those terms must be squared terms, all right? And then the second vital part in this method is that we need to know how, that should be an H, sorry, we need to know, let me just put a little line there, we need to know how to square root terms, which I'm going to be showing you just now, just in case we have forgotten. Okay, so let's look at some examples. I'm just going to zoom in a bit. Let's look at some examples on how to factorize using the dots method or the difference of two squares method. So again, you ask yourself, are there any highest common factors in this question? And there is not. So you move on and you say, can I do dots, the difference of two squares? And actually, yes, you can. Why, Mr. Hing? Because dots, if we have a look at what it stands for, D stands for the difference of, so there's a subtraction sign, and there are two terms, the x squared, the y squared, and those terms are squared terms, okay? And mathematically, I'll show you how do we know that it is squared terms. Well, if we look at the x, if we take x times x, that is x squared. Because remember, anything times itself will be itself squared, so it is a squared term. And then the other one, the y, is y times y, which is y squared. So these two terms are squared terms, and therefore you can go and continue your method. So I hope that is clear. Now let's go see how do we actually answer the question if it's asking us to factorize. So I've put some notes over here. So what we're going to do is we are going to open up some brackets. Number one says brackets. So what you do is you open up two sets of brackets like that. Step number two, you put a plus and a minus sign. It doesn't matter which bracket you put it in. You can do plus, or if you don't want to do a plus there, you can do a minus there and then a plus there. It doesn't matter, okay? As long as if there's a plus here, there must be a minus there, or if there's a minus there, there must be a plus in this bracket over here. So let's have a look and see step number three. Now, how do we know what gets filled in over here, these blank spots in the bracket? How do we know what goes there? Now, this is probably the most, I don't want to say most important part because they're all important, but it is a very important part. So now we need to know how do we square root these terms, and that answer that we get after square rooting will go into these places. So let's take each one. We say, okay, now the x squared, which is the x squared over here, when we get an answer from this, that is the answer that will go into our bracket. So I want to show you how to do that in case you forgot. So you say the square root of x squared. Now, how do you do that? Well, there's a rule that says if you take the x and the square, this 2 over here comes from this 2 over here, and you divide it by what's on the outside of this root sign, and there's an imaginary 2 there, so you divide it by 2, and this answer, 2 divided by 2, is 1. So therefore you'll just end up with x to the imaginary 1. Okay, I hope that makes sense. I'm going to do it again. So, and then you take this answer x, and you put it over here, and that's how you find out what gets left over. I'm going to do the same method now with the y squared. So how do you find out what's left over here, left over there? You take the square root of the y squared, and this simplifies to the y squared. Now this 2 over here is this 2 over here, and then you divide it by what's on the outside, the imaginary 2 there, and again we'll get just y, and then you put that answer over there. And that, guys, is literally how you do the difference of two squares method. That is your final answer. Let's have a look at another question. I'm going to go through it really slowly, and then I'll answer a few questions with you, and you can actually do them by yourself. Pause the video and see if you get it right. So we have a question in our test, for instance, and it says factorize, and we need to know how do we factorize. So remember, the first question you ask yourself, can you do the HCF method? Always ask yourself that. In this case, no. Between the coefficients 100 and 9, there's no common factor or highest common factor. And a squared, b squared, no. So it does not apply to us. Thank you very much. Then you go on and you say, can I do dots? Can I do the difference of two squares? Well, yes, you can. There's a difference sign, a minus sign. And this term and this term are squared terms. Okay, so remember, let me just show you the steps over here. Step number 1, you open up a set of brackets. You put plus, minus, or vice versa. And then you need to go and square root these two terms. Okay, so let's do that together. I'm going to do it slowly. So it's the 100a squared. We'll do that one. And then the square root of the 9b squared. So let's do that together. Now, remember, guys, when we have a square root of a term that has a coefficient, the 100 is the coefficient here, over here the coefficient is 9, and we have variables, we need to kind of do them separately. So let's have a look and see how we do that. So the square root of, firstly, 100 is 10, because 10 times 10 is 100. And then I'll do it one more time, or a few more times. How do we simplify this? Well, we take the a squared. Remember, this 2 is this 2 over here, and we divide it by what's on the outside, the imaginary 2, and we get a to the imaginary 1. So we put that and we join it to the 10. So that is the simplified version of the square root of 100a squared. So we put that over here, 10a, like that. Let's have a look. Oh, and we remember, also put it over there. And then we do the same thing over here. So the square root of 9 is 3, because 3 times 3 is 9. And then the same rule goes for the b squared. So it will just be b, like that over there. So we take that answer and we take the 3b and 3b. And that is your final answer, full marks. Okay, guys. So let's have a look. I'm still going to explain in detail over here, but just not as much, because we just did those examples. But what I would suggest is pausing the video, trying by yourself, and seeing if you can get the right answer. And then I'm gonna do it now, and then you can almost test yourself, see if you're getting it right. Okay, so let's go ahead and do that. So you ask yourself the question: is there highest common factor? In this case, there is not. So you say, can we do the dots method? Yes, we can. There's a difference of two terms which are perfectly squared terms. So you open up two brackets, plus and minus, or vice versa. You take the 4, you square root that. That is going to give me 2. So we put 2 and 2. You look at the 25, a to the 4, 25, a to the 4. And we simplify that. The square root of 25 is 5. And then remember, how do we do this one? A to the 4. That 4 is that 4 over there, and we divide it by what's on the outside. There's an imaginary 2 because it's a square root sign. So we divide it there, and that would become a to the 2. So the 5a squared comes over here. 5a squared, 5a squared. And those are our full marks over there. Right, let's continue. Let's go on to letter B. So we ask ourselves, is there any highest common factor here? No, there is not. So we move on to, can we do difference of two squares? Yes, we can. There's a difference sign, and there are two terms that have been perfectly squared. So let's have a look. So again, we open up two sets of brackets, plus and minus, or vice versa. We take the 9, we square root that 9, and that is going to give us 3. So it's going to be 3 and 3. If you want to do this in your test, just make sure that it's not a part of your answer, because you don't want that getting marked. So these are our notes here. And then the square root of this one. Now, how do we do the square root of this term? This one's quite nice and interesting. So once again, we have a coefficient of 4. Okay, so we're going to square root that, and then we'll square root each variable. So let's go ahead and do that. We all know now the square root of 4, 2 times 2 is 4, so it's going to be 2. Then, remember, the squared over here gets divided by the imaginary 2 on the outside, so that will just become x to the imaginary 1. And the same thing will happen, the exact same thing will happen with the y. So the y will come over here. Okay, and that is literally what we put in over here. So we get 2xy and we get 2xy. And that is our final answer. Nice, guys. Let's continue. Last one. So we have this question over here. It says factorize. Is there a highest common factor here? Now, guys, there is a highest common factor over here. I've actually underlined them for you. Okay, so what ends up happening is we must take out a highest common factor first, because whenever you get asked to factorize a question, you must factorize it fully. Okay, so I did the HCF method in a previous video, so I'm just going to do that now. If you're getting lost, you can just go back to the previous video, but I'm going to do that now, and then you'll see that we should continue to factorize after. So I'm just going to do the HCF method quickly first. So you ask yourself, between the two terms, is there HCF? Between 36, the coefficient, 36 and 4, there is a highest common factor. 36 and 4, the HCF is going to be 4. That shouldn't be there, sorry. The HCF, let me just put that there. The HCF is 4. Because 4 goes into 4 and 4 goes into 36. So you're going to say the HCF is going to be 4. And then, is there highest common factor with my variables? No, there's not. There's not x and y's with this term. So 4 is the highest common factor. You open up a bracket. You divide the terms by 4. I don't know if you remember from the previous video. You'll say 36 x squared y squared divided by the HCF 4, and that's going to give me 9x squared y squared. So we put that in here, 9x squared y squared. Then we take our other term. Remember, these are our notes. We take the other term, minus 4 divided by the HCF 4, and that would give me negative 1. So we get negative 1 over here. So that is the HCF method done and dusted. Now we have to ask ourselves, from this place that we're at over here, can we factorize it again? Because when you get asked to factorize, you must always factorize as much as possible. So if you look over here with me, guys, if you draw your eyes to what's inside of this bracket over here, you'll see that there is a difference of two squares that can occur over here, because there's a subtraction sign over here, right? And there's two terms in the bracket, and both terms are perfectly squared terms. So we can go and apply that the dots method over here. So what you'll end up doing, you write the 4 as is, and then you simply just factorize how we've been doing the dots method the whole time. So you open up two sets of brackets, you put a plus and a minus, or vice versa, and then we go and we square root. So we square root the 9x squared y squared. The square root of 9 is 3, and then the square root of x squared is going to be x. The square root of y squared will be y. So we put that in there. 3xy and 3 xy. And then the square root of 1 is simply 1, because 1 times 1 is 1. And that will come over here. And that now is our final answer. So I just wanted to include a more difficult and tricky one where we had to incorporate another method. So yeah, guys, with all of that being said, I hope that was helpful. If you got a little bit lost, don't be afraid or don't hesitate to rewind and just rewatch and just listen and take careful notes of how to do things, okay? But yeah, just keep a lookout for the trinomial and grouping method, which I'll try bring out today as well. But with all of that, guys, if there's any questions, don't forget to comment. And then, yeah, it's helpful if you like and subscribe. It does share the content to other viewers who need the help.